Good morning, my dear students. Today will be the third session on three address code statement, and I was discussing the translation of an assignment statement, right? So yesterday we have seen how the three address codes are implemented by using quadruple, triple, and indirect triple representation, and to some extent we also have seen the translation process of an assignment statement. Okay, so here we have to translate the given assignment statement. So what is the meaning of this? The meaning of this is to generate an intermediate code for this, right? So what is the intermediate code that we can generate for an assignment statement? So it is basically a sequence of three address code statements. Okay, so what is the provision for us to generate the three address code statements? So here we will be using the syntax directed translation, syntax directed definition using synthesized attribute. Using synthesized attribute. Okay, so you all know that the syntax directed definition is a notational framework which is an extension of a context-free grammar. So according to this, we have the set of attributes defined for all the grammar symbols, and the set of the semantic actions are attached with every productions, right? And these semantic actions have to evaluate the attributes of the grammar symbol whenever they are called at appropriate time. So here the appropriate time would be, in case of bottom-up parser, it is just before the reduction, and in case of top-down parser, it is just after the expansion. Okay. Now, when you are actually writing, when you are using the STD, okay, so there are few important points you have to remember. The first point is what kind of an input statement you are giving. Since you have to generate an intermediate code, okay, so what kind of an input statement you are giving. Let us suppose this is what is my input statement. So these are two examples that I am going to consider in my discussion. So once you know what kind of an input statement you are going to get, okay, so the next thing is, see, you have to generate the intermediate code for this expression, which is basically a sequence of three address code statements. That is, for this statement, okay, for this assignment statement, this is the sequence of three address codes that are generated, and for this assignment statement, these are the sequence of three address codes that are generated. Okay, now before the intermediate code is generated, first the input statement has to be verified. Okay, first the input statement has to be verified. Okay, so in order to do that, we have to first describe the structure of, an assignment statement. So as you can see, the assignment statement is a statement composed of a variable, okay, followed by an assignment operator, and then followed by an expression, right? So for this you have the rule that is S derives ID equal to E. Okay, that is what is my production that I am going to write, right? And then the expression here is composed of all binary operators including unary operators. So just for simplicity, let us assume that we are going to consider one additive operator and one multiplicative operator. So my expression is composed of, first let us say one additive operator, so the production is E derives E plus E, and one multiplicative operator, let us say E derives E star E. You can also have the expressions, the parenthesized expressions. So my expression also takes, or it is composed of parenthesized expression, and then minus E is unary minus, and then my expression is also a single operand, that is single identifier. Okay, so this grammar is going to describe the structure of an assignment statement. So here I have considered an ambiguous grammar. Okay. So why, you may ask, why I have considered the ambiguous grammar? Since I have to explain the syntax or directed definition, there are some redundant reductions, so that I want to avoid. Okay, so if I make use of this ambiguous grammar for assignment expression statement, okay, some of the redundant reductions I am going to eliminate, so that my explanation is easy. So I am going to consider the ambiguous grammar. Okay, so this is what is my grammar to describe these type of assignment statements. Now, when the expressions are written, you have the operands. Okay, when the expressions are written, you have the operands bounded by the operator symbols. Okay, so you may have different types of variables. Okay, different types of identifiers. Okay, so let us assume that for simplicity, the primitive data type, that is what is integer. So all the operands are of type integer. Okay, all the operands are of type integer, and here since we are using SDD, using synthesized attribute. Okay, so once we know what kind of an input statement you are getting, so we have described the assignment statement by using a notation called as a grammar. Okay, so I use the grammar. Next thing is, you must define the attributes for the grammar symbol. Okay, you must define the attributes for the grammar symbol. So before you define the attributes for the grammar symbol, you should know what type of attributes you have. Of course, you have a synthesized attribute. Okay, so what value it can have. So you have to first understand what value an attribute of a grammar symbol can have. Okay, so here it could be an integer. Okay, it could be a float. It could be a number, right? It could be a string. Okay, it could be a boolean, and so on. Since we are going to generate the sequence of 3 address codes, okay, my attribute is of type string. Okay, my attribute is of type string. Okay, so if the attribute is of type string, okay, and for each grammar symbol, the attributes are referred by a dot code. Okay, so if E is the grammar symbol, then I can have E dot code as the attribute which is going to represent a string valued attribute. Okay, so dot code is the notation that we use to refer the string valued attribute. Okay, string valued attribute. Right? Now, here there are 2 types of grammar symbols. As you can see in the grammar, okay, there are 2 non-terminal symbols. Okay, there are 2 non-terminal symbols, and there are around 6, 7, 8, 9 terminal symbols. So all these things are called as, all these combination of terminals and non-terminals is called as a grammar symbol. So we have to define the attributes for this. Suppose if you take a grammar symbol E. Okay, suppose if you take a grammar symbol E, so E will have 2 types of attributes. Okay, one is E dot code. One is E dot code. So E dot code is nothing but is going to hold the sequence of 3 address codes, since we are going to generate the intermediate code for the assignment statement. So E dot code is a string valued attribute. So this is going to define the sequence. This is going to have the sequence of 3 address codes evaluating the expression. Understood? And E dot address is the value associated with that sequence. Okay, so it means that for grammar symbol E, there are 2 types of attributes. One is E dot code, which is going to have the sequence of 3 address codes evaluating the expression, and E dot address is the value associated with that sequence of 3 address code. So if I take a production S derives ID equal to E, okay, if I take a production S derives ID equal to E, right? So I have S dot code. So S dot code is the sequence of 3 address codes evaluating the whole assignment statement. So that sequence of 3 address code, if I take this particular assignment statement, so my S dot code is going to have this. Okay, S dot code is going to have, and of course S dot address you will also have, and that value is nothing but it is W. So at this moment it is redundant. Okay. Now, if I take a production, E derives E plus E. Now we have identified what are the attributes. Okay, we have identified what are the attributes. Now we must attach the semantic actions for every production. Okay, so we have to attach the semantic actions for every production, and these semantic actions have to evaluate, they have to generate the sequence of 3 address code, which is an intermediate code for that particular construct. Okay, now let me take production. So E derives, since there are 3 instances, let me indicate 1, 2 to differentiate these gamma symbols. So all are same. So just to differentiate in the explanation, okay, I have E1 and I have E2. I have given the subscript. Okay. Now here the semantic actions that we attach for every productions, okay, they have to be called at appropriate time. So here the appropriate time is, so I am going to consider the bottom of parser for explanation. Okay, so just before the reduction, okay, just before the reduction, okay, I have E1 dot code. I have E1 dot code, which is the sequence of 3 address code evaluating this expression, and the value of that would be E1 dot address. Okay. Similarly, I can have E2 equal to E2 dot address, E2 dot code, sorry, E2 dot code is the sequence of 3 address codes evaluating this expression, and E2 dot address is the value associated. So before the reduction, all these things are available with us. Okay. Now at the left hand side of the production, which is the head of the production, okay, you also have a E dot code, which is to be defined. Okay, which is to be defined, and also E dot address, the value associated with that. This also is to be defined. So for that, we have to write a semantic actions. So your semantic actions just before the reduction, when it is executed, that is when E1 plus E2 is reduced to E, okay, you must generate a new 3 address code. Okay, you must generate a new 3 address codes to evaluate the corresponding operator here. That is the plus here. Okay, now that has to be defined in terms of the value of the sequence of 3 address codes for this, which is E1 dot address, and plus the value of sequence of 3 address codes of this particular expression, which is E2 dot address. Okay, and that will be my E dot address. So first have to generate a new 3 address codes evaluating this expression. This expression is, now here it is addition, right? So what I will do, so in order to see here, since you are going to generate the 3 address code, the value of these is to be stored somewhere. Okay, so you have to request a temporary for E dot address. Okay, so you have to request some temporary for E dot address, which is going to have the value associated with the sequence of productions of this. So this sequence of production is to be defined, that is by a semantic action that I am going to write. So first, when I execute the semantic actions, it has to first generate a new 3 address code to evaluate this using the E1 dot address, E2 dot address. That becomes E. Okay, so E dot address. So E dot address is equal to, so here if you just see the productions, see here, in this case we must have a sequence of 3 address codes, that is E1 dot code and E2 dot code we already have. Okay, and these are evaluated in some place. So E1 and E2, E1 dot address and E2 dot address, they are in some temporary. Okay, or they could also be variables, or they could be a constant. Okay, so I have E1 dot address and E2 dot address. Now semantic rule must generate a new address. So in order to do that, you would be writing this. Now the semantic rule must generate a new 3 address code statement that evaluates the corresponding operation. The operation is here plus. So I have e dot address is equal to, that is the sequence of the value associated with this expression, that is e dot address equal to value of this sequence, value of this expression which is in some temporary, that is e1 dot address. Okay, similarly value associated with this expression which is e2 dot address. Understood? So this is what is the new 3 address code, that is what is generated, right? And this must be concatenated with the sequence of 3 address codes of e1 dot code, e2 dot code. So whole of this becomes a e dot code for this. Understood? So e dot code is going to have the semantic action what you write. Okay, it is going to define the sequence of 3 address codes for this, which is e dot code. So this contains the sequence of 3 address codes of e1, okay, followed by a sequence of 3 address codes of e2, that is e2 dot code. In the earlier one it is e1 dot code and e2 dot code, followed by a new 3 address code, that is what is generated. Okay, so I have written the semantic action like this. So first I am going to request the temporary, okay, e dot address is what? It is going to hold the value of a sequence of 3 address codes for the head of a production. Okay, that needs to be computed. I am going to get the temporary here. Okay, so my e dot code is first I am going to get the sequence of 3 address codes of e1 dot code. Okay, this is the concatenation symbol. Get concatenated with the sequence of 3 address codes of e2, that is e2 dot code. And then I have to generate a new 3 address code, and that has to be appended, that has to be concatenated. Okay, so in order to generate a new 3 address code, let us assume that we are using a gen function. Okay, we are using a gen function, and this is what is the argument. So here the new 3 address code that is to be generated is the value of this expression, which is e dot address, is in some temporary, value of this, okay, again which is in some temporary, okay, with the operation that becomes a value of this. That's why it is written as then e dot address, which is the value associated with the head of the production, is equal to value associated with e1, which is e1 dot address, which is in some temporary, followed by the corresponding operator, which is plus here, then followed by the value associated with the expression 2, okay, which is again a temporary or a name, so which is e2 dot address. So this is what is my semantic action. Okay, so this is what is my semantic actions for this production that must be attached to this. Okay, so as you can see here, just before the reduction, okay, when this particular function is when this particular production is called, when e1 plus e2 is reduced to e, okay, I have e1 dot code, I also have e2 dot code, e1 dot address, e2 dot address. Okay, so I have to define e dot code, the sequence of 3 address codes for this, and e dot address is the value associated with that sequence. Okay, so I am going to write, first I am going to request the temporary, which is going to store the value of the operation, that is plus here. So e dot address equal to new temp. Then the e dot code is equal to, first I am going to take the e1 dot code, followed by e2 dot code, then concatenated with a new 3 address code that I am going to generate. Okay, which is e dot address equal to e1 dot address plus e2 dot address. So this is what is my semantic action that must be attached to this. Okay, so just before the reduction, this is get executed, and accordingly the corresponding intermediate code is generated. Okay, so since here I have taken plus here, so this can be extended for any operator, right? Now there is one more thing here. Let me consider a production S derives ID equal to E. Okay, now here when ID equal to E is the head of the production and ID equal to E is the body of the production and S is the head of the production. So when this production is used for reduction, so just before the reduction, okay, I have a sequence of 3 address codes evaluating this expression, which is E dot code, and I also have the value associated with that sequence of address, that is E dot address. It means that to evaluate E into some temporary, and then semantic rules. Now here I am going to generate the semantic, I have to attach the semantic actions to this particular production. So that rule will generate the 3 address code X equal to E address. That means here you should get the instance of an ID from the symbol table. Okay, you have to get the instance of an ID from the symbol table. So here the value of the expression is going to stored in the variable which is available in the symbol table. Okay, so I have to get the instance of an ID, the corresponding variable from the symbol table. Let us say it is X. So I must now generate a 3 address code X equal to E dot address. That means the value of this expression is E dot address. Okay, to evaluate that value you have the sequence of 3 address codes, that is E dot code. So value of this is nothing but, yeah, that is, let us suppose X is the variable. So I can generate a 3 address code X equal to E address. So E address is going to have the value associated with the sequence of 3 address codes evaluating this expressions. So my semantic action here is S dot code is equal to first the sequence of 3 address codes for this, okay, followed by a new 3 address code that is to be generated, which is X equal to E dot address. That means I have to get the value, I have to get the instance of an ID from the symbol table. So let us assume that I have this statement, this top indicates the symbol table name, okay, and get is going to get the corresponding name, corresponding instance of an ID from the symbol table. So top dot get ID dot lexme is going to retrieve the instance of an ID from the symbol table. So you have, let us say, if X is the variable name, so X equal to E dot address. So E dot address is the value associated with this. So this is what is my new 3 address code, that is what is generated, and that must be concatenated to E dot code. So whole of this becomes S dot code, right? So this is second type of production we have in the grammar. Next one is I have E derives ID. Okay, so in this production, when ID is reduced to E, okay, when ID is reduced to E, right, the identifier say X itself is going to hold the value of the expression. Understood? So here no 3 address code is generated. No 3 address code is generated. Only thing is we have to define E dot address to point to the symbol table entry for an instance of ID. Okay, so here E derives ID is a production. Okay, I'm going to get the instance in E dot address which is equal to top dot ID dot lexme. ID dot lexme is the instance of an ID. You have a variables, you have the variables entered in the symbol table. So the instance of this particular ID is taken. Okay, so that is what is my value of the expression. Then no code is generated. Here no code is because my expression is a single identifier, and that is going to hold the value, which is E dot address. Okay, so I must point this E dot address, the value of the expression, to point to the symbol table entry for some instance of ID. So this is what is my semantic action that I am going to write. So E dot address equal to top dot get ID dot lexme. It's going to get the corresponding variable name associated with ID, and then no E dot code is generated. So here top is nothing but a symbol table name, and top dot get retrieves the entry from the symbol table for an corresponding ID. Okay, so like this you can attach these semantic actions. So when these semantic actions are called at appropriate time, here in this case it is reduction. So just before the reduction, okay, you have the sequence of 3 address codes for body of a production, and you also have the value associated with that. Okay, and accordingly the statements are written, they get executed, and then they generate the required intermediate code as the sequence of 3 address codes. Okay, so I have just consolidated the semantic actions that are being attached to every production. So this is what is my grammar. These are the sequence of productions. So for the first production, I have the semantic rules that is attached. Similarly, E1 plus E2. Similarly, star. Okay, So whenever you are generating the 3 address code, new 3 address code you are generating with a particular binary operator, you have to request a temporary. That's why e dot address equal to new temporary. So this will get a new temporary. Okay. So this is what is the syntax directed definition with synthesize attribute to translate an arithmetic expression. Okay. Now let me just discuss how these semantic actions are get executed. Okay, and when they get executed, how they are going to evaluate the attributes, and then finally how they are going to generate the intermediate code, which is the sequence of 3 address code. Okay, so let me explain these semantic rules in connection with say LR parser, right? So let me take an expression w equal to x plus y into z. Okay, so here w, x, y, z. These are all variables. These are all programmer defined variables. Okay, right? Now, what is the sequence of 3 address code that I have to generate? This is what I am supposed to get. This sequence what I am going to get. So here, this is an assignment statement which is identified as yes. Okay, my yes dot code, finally my yes dot code is nothing but this. And yes dot address, which is irrelevant, is equal to the value of this whole sequence, which is w. Now let us see how this is generated. Okay. Now we'll have appropriate shift reduce actions, right? So the input is scanned by the lexical analyzer, which is going to work in connection with parser, right? So I have at present there are 2 shift actions, shift w, okay, and equal. Now not 2 shift actions, there are 3 shift actions. So internally these w, x, y, z, they are represented as an ID. Okay, so ID nothing but they are the abstract symbol, okay, used by the compiler. Okay, ID is an abstract symbolic name used by the compiler for all these identifiers. Okay, so here I am going to write actually the corresponding identifier, that is W. Okay, so in the first instance I am going to shift plus, then equal, then the variable x. So my next action is reduce. So reduce with production E derives ID. Reduce with the production E derives ID. Now see here, when ID is reduced to E, okay, I must not generate any 3 address codes. No 3 address code is generated because the value of the expression is nothing but it is a single identifier. Okay, I should get the instance of an ID here. Okay, from the symbol table. That is what is my E dot address. Okay, so my E dot address, here it is E dot address. What it is? The corresponding instance of an ID. What is the ID here? Which is x. So I am going to get x here. I am going to get x. Right? Next. Third step, again, shift plus and y. Shift plus and y is my next action performed by the LR parser. Right? Then fourth one, reduce. Reduce with production E derives ID. Okay. So again here, when ID is reduced to E, okay, I am not generating any 3 address code. Only thing is I am just getting the value which is in E dot address. So my E dot address is the instance of an ID. Okay. So E dot address, in this case here it is Y. Understood? At present I don't have any E dot code that is generated. Right. Next, fifth step. Next action is again shift star and Z. Shift star and Z. Right? So my next action is again reduce. So reduce with production again, E derives ID. So here also no code is generated. So I have E dot address equal to the instance of an ID is Z. Okay, here at present I have not generated any sequence of 3 address codes. I only have the value which are nothing but the operand values X, Y, Z. Okay, my next step is reduce. Reduce. Since here, if you just see the expression, star has got hash priority, that is what is evaluated. Okay. Now my next action is reduce using the production E derives E star E. I think you all have to understand the appropriate shift reduce actions, and whenever a particular reduce action is performed, what is the appropriate production that you are using for reduction. I think you know all those things. Okay, let me not repeat all those things once again, right? So when E star E is reduced to E, okay, I have the sequence of 3 address codes for this. Okay, I have the sequence of 3 address codes for this. What is that? Which is null. Okay, and the sequence of 3 address codes, next is the value associated with that sequence, which is E dot address, that is X. Okay, so this is available just before the reduction. Similarly, for this grammar symbol, okay, I don't have any sequence of 3 address codes generated, but however, I have the value. Okay, that value is nothing but the E dot address, which is Z. Right. Now, I have written a semantic, I have to use this particular production for reduction. So just before the reduction, okay, I just told that we have the addresses available. Address, the address of this, that is E1 dot address, E2 dot address, they are available, which are nothing but Y and Z. Okay, now I have to define E dot code and accordingly E dot address. So to E dot address is going to hold the value of this, so I have to request a temporary. So that's why you have E dot address equal to new temporary. So I'm going to request, let us say, a T1. I'm going to request, let us say, a temporary T1, which is going to hold the value of the new 3 address code that I'm going to generate. Okay, and what is the new 3 address code, that is what is generated? That is this. So E dot address, so what is my E dot address? That is a requested new temporary, that is T1. Okay, that is T1 equal to what it is? T1 equal to, sorry, here. T1 equal to E1 dot address. What is E1 dot address? There is no E dot code, E1 dot code, but however we have the value E1 dot address, which is Y, which is Y. So Y into, okay, so what is E2 dot address? It is Z. Okay, so this is what is my new 3 address code, what is generated. Okay, and this new 3 address code has to be concatenated with, okay, E1 dot code and then E2 dot code. So that becomes a sequence of 3 address codes for the head of the production. But here I don't have E1 dot code, which is empty, which is null. Similarly, I also have E2 dot code, which is also null. But however, I have the value E1 dot address. I also have the value E2 dot address. Here it is X and here it is Y. Okay, and this is what is the new 3 address code, that is what is generated. So what is my entire E dot code? My entire E dot code is only E1 dot code, which is null, followed by E2 dot code, which is also null, followed by a new 3 address code, that is what is generated. That is, this is what is my first 3 address code, that is what is generated. Understood this? Okay, my next action is 8. The action is reduce. Reduce with a production E derives E plus E, E1 plus E2. Now just try to understand when this particular production is used for reduction. Okay, I have the attributes of these body of a production. Okay, now here I have to evaluate E dot code. I also have to evaluate E dot address. Okay, so before we evaluate the before we generate the 3 address code, I must have the value associated with this. Okay, that means I have to request a temporary. My next temporary is, let us say, T2. I'm going to request a new temporary. Since it is plus, these are the semantic actions that are executed. So I'm going to request a temporary. My next temporary is, let us say, T2. Okay, so just before the reduction, I have E1 dot code, the sequence of 3 address codes evaluating this, which is null, which is null. So you can indicate here E dot code equal to null. Here also E dot code equal to null. Okay, and E dot code equal to null. Right? Now I have E1 dot code equal to null, but however I have E1 dot address which is X. Okay, similarly E2. So I have E2 dot code. What is E2 dot code? My E2 dot code is T1 equal to Y into Z. Understood? My E2 dot code is T1 equal to Y into Z. And what is my E2 dot address? My E2 dot address is T1. My E2 dot address is T1. Okay. Now, when this particular production is used for reduction, okay, I am going to generate a new 3 address code. Okay, since I have requested a new temporary, this is T2. So T2 is equal to the value of this expression, which is E dot address. So what is E dot address here? This is nothing but it is X. It is X. Right? Next, I have the value associated with the 3 address code of this. What is the value associated with this? Which is T1. T1 equal to Y into Z is my 3 address code generated, and E dot address, which is T1, is the value associated with that. Okay, so my T2 equal to X plus E2 dot address. So here it is X, here it is X, okay, and here it is T2. Okay, E2 dot code is this sequence, the value is in T1. So T2 equal to X plus T1 is the new 3 address code, that is what is generated, and this has to be concatenated. Just see here. First, I am going to take my sequence of 3 address codes of the head of the production is, first I am going to take the E1 dot code which is null, okay, then followed by E2 dot code. My E2 dot code is this. Okay, first I am going to write T1 equal to Y into Z. So this is first concatenated with null, so you are going to get this. Next is followed by a new 3 address code, that is what is generated, which is T2 equal to X plus T1. So my sequence of 3 address codes are T1 equal to Y into Z, T2 equal to X plus T1. So these are the two sequence of 3 address codes. This becomes my E dot code. Okay, so sequence of 3 address codes to evaluate the head of the production, and what is its value? That is E dot address, which is nothing but it is T2, which is nothing but T2. Okay. Okay, next. What is the next course of action? Ninth step. So it is again reduce. So reduce with production, S derives ID equal E. That is this production. Understood? So I have to define S dot code. Of course, S dot address is irrelevant here. You can also take the value of that expression as S dot address, which is irrelevant here. Okay, so what it is going to have? The E dot code. E dot code, the sequence of 3 address codes evaluating this. What are the sequence of 3 address codes evaluating this expression? This is going to have these two sequences. That is T1 equal to Y into Z, T2 equal to X plus. So these are the two sequence of 3 address codes evaluating this expression. Okay, then concatenated with, I should get a new 3 address code is to be generated, which is X equal to E, where X is the instance of an ID. Now what is X here? My X is W here. Understood? Which is an instance of my ID in the expression. Okay, so I must generate a new 3 address code as, just here, first I will get the instance of an ID from a symbol table, which is W equal to E dot address. What is the E dot address? The value associated with this sequence, which is T2. Okay, so what I am going to generate? I am going to generate W equal to T2. W equal to T2 is my new 3 address code that is generated, and that is get concatenated. Okay, so my S dot code will have first this 3 address code, that is T1 equal to Y into Z. Next T2 equal to X plus T1, W equal to T2. So since we have reached the start symbol, okay, the parsing process is completed. Okay, simultaneously an intermediate code is generated, which is a sequence of 3 codes for this particular assignment statement. So you have T1 equal to Y into Z, T2 equal to X plus T1, and W equal to T2. So this is how an assignment statement, right? This is how an assignment statement is translated into a sequence of 3 address codes. I hope you have understood this. Okay, so I have one more example, little complicated example. Okay, let me take that. Now if you just scan, this is what is my arithmetic assignment statement, and these are the sequence of 3 address codes has to be generated through the semantic rules. Okay, so before that, manually if you find the sequence of 3 address codes, B minus C is the first expression that is evaluated in some temporary, so you have T1 equal to B minus C. Then this is the next operation, so you have A into T1 into some temporary. Okay, next is this is evaluated, so T4 equal to T3 equal to A plus T2. Next is again B minus C, sorry, this B minus C, so that is in some temporary, so T4 equal to B minus C. Next, this star, so I have T5 equal to T4 into D. Then this, that is T6 equal to T3 plus T5, and then X equal to T6. So this is what is to be generated for this assignment statement. Okay, now let us see how it can be done. So what are the actions? Again, shift X equal and A. Right? So the next action is reduce with a production E derives ID. Okay, so here no code is generated, E dot code equal to null, okay, and E dot address equal to the instance of an ID which is A here. Okay, next, third one, again shift plus and A. Fourth one, again reduce E derives ID. Okay, so here no code is generated, which is null. Okay, and however you have the instance of an ID obtained from the symbol table, which is again A. Next, fifth step, shift star opening parenthesis and B. Okay, sixth one, reduce E derives ID. Okay, so no E address code is generated, that is E dot code is null, E dot address equal to B here. E dot address equal to B here. Next, seventh step, shift, okay, minus and C. So 8, again reduce, again with the production E derives ID. Reduce with the production E derives ID. So I have E dot code equal to null, no code is generated. However, E dot address is the instance of an ID, which is C here, which is C. Okay, next, ninth step, reduce. What is the production? E derives E1 minus E2. E derives E1 minus E2. E derives E1 minus E2 is the production that is used for reduction. Okay, now just before the reduction, I have E1 dot code which is null. Okay, I also have E1 dot address which is B. Okay, and for this grammar symbol, E2 dot code which is null. Okay, and E2 dot address which is C. Right? So first I am going to generate a new 3 address code, that is this. Okay, so I have to request a temporary, let me request a temporary T1. So T1 equal to E1 dot address, my E1 dot address is B. Okay, operation is minus. You can also write for E derives E1 minus E2 in a similar fashion. Just have to change this symbol. Okay, now T1 is a new temporary, that is what is requested. My E1 dot address is B. Next is operator minus the E2 dot address, which is C. So T1 equal to B minus C is my first 3 address code what is generated, and this is what is here. Okay, next 10th step, shift closing parenthesis. Then 11, reduce E with parenthesis T. So here there is no operation involved. Okay, so you have E1 dot code as a sequence of 3 address codes evaluating this. You also have E2 dot code, E1 dot address is the value associated with that. Since there is no operation, okay, what is my semantic actions to evaluate the attribute of this, which is E dot code equal to just E1 dot code, E2 dot address equal to E2 dot address. You can see here, E dot address equal to E1 dot address, E dot code equal to E1 dot code, right? So what is the expression here? I have my E dot code is B minus C only. Understood? Next, 12th step, next action is reduce again. Reduce with production E derives E star E. Now just see here, just before the reduction, I have the sequence of 3 address codes to evaluate this, which is null. That is this part. And the value is A. And the sequence of 3 address code is null, and the value associated with the sequence is A. Similarly, E2. Okay, I have E2 dot code as T1 equal to B minus C, right? And what is my E2 dot address? E2 dot address is the value associated with the sequence is T1. Okay, so what is the new 3 address code? That is what is generated. Before that, you request a temporary, let me say it is T2. So T2 is going to hold the sequence of 3 address codes of this particular body of a production, that is E dot address. Okay, so E dot code is, first I am going to generate a new 3 address code, that T2 equal to E1 dot address, which is null. Okay, then E1 dot address is A. I'm going to write A. The operation is star, and then E2 dot address is T1. So A into T1 is the next 3 address code, that is what is generated. So this is what. Okay. Next, 13th step. Action is reduce. Reduce with production E derives E plus E, E1 plus E2. Now just here, before the reduction, I have E1 dot address and E1 dot code. So there is no E1 dot code, that is this, right? And E1 dot address is this A. Okay, and E2 dot code is this, and E2 dot address is T2. Okay, so what is the, I have to first define the value associated with the sequence by requesting a temporary, that is E dot address. So let me take next temporary, requested temporary is my T3. Okay, so T3 equal to E1 dot address. So what is this E1 dot address? Which is A. Okay, then E2 dot address, which is T2. Operation is plus, so T2. So A plus T2 is the new 3 address code, that is what is generated. So E dot code is first this, next this, and then next. So I have 3 sequence of 3 address code that are generated, that is this part. Okay. Next, 14th step, shift plus, that is this plus this and this, okay, opening and then and B, right? So next is reduce. Reduce is E derives ID, so there is no E dot code, null E dot address equal to B. Get the instance of an ID which is B here. So 16th step, right? Shift minus and C. Okay. Then 17th reduce. Again E derives ID. Okay. So no code is generated. E dot code equal to null. Then E dot address equal to C. Right? Then 18th step, reduce. With production E derives E minus E1 minus E2. Okay, right? So I have the sequence of 3 address codes evaluating this, which is null, and E1 dot address is B. Similarly here E2 dot code is null and E2 dot address is C. Okay, so new 3 address code, that is what is generated. First you take a temporary, my next temporary is T4. T4 equal to B minus C. Is my new 3 address code, that is what is generated. So this has to be concatenated with all these things. Understood? So, okay, sorry, E dot code is just T4 equal to B minus C, right? Next, 19th, shift, closing parenthesis, right? Then 20th, reduce with E derives parenthesized E. Okay, so here E dot code equal to T4 equal to B minus C and E dot address equal to T4. That is this. No code is generated since there is no operation. So next is shift star and D. 21st, second step, reduce with production E derives ID. So here E dot code is null, okay, and E dot address is instance of an ID which is D here. Okay, next is 23rd, reduce with production E derives E1 plus star E2. Okay, that is this part, right? So I have E1 dot address as what? E1 dot address as T4, okay, and E1 dot code as T4 equal to B minus C, and E2 dot code as null, and E2 dot address is D. Okay, so I have to evaluate, I have to generate the new 3 address code by requesting a temporary. My next temporary is T5. So T5 equal to E1 dot address, which is T4, and E2 dot address, which is D. So into D is the 3 address code, that is what is generated, and this 3 address code has to be concatenated with this 3 address code. So these two sequence of 3 address codes represents the 3 address code for the head of the production. Okay. So next I have E derives E plus E. Okay, E1 plus E. Now see here, I have E1 dot address. So my E1 dot address is what? Which is T3. My E1 dot address is T3. Right? That is here. Right? And E1 dot code is this sequence. E1 dot code is this sequence. Similarly, E2 dot address is T5, and E2 dot code is T4 equal to B minus C, T5 equal to T4 into D. Okay. Now I have to generate a new 3 address code. First request a temporary. My next temporary is T6 equal to E1 dot address, which is T3. Okay, plus E2 dot address, which is T5. So this is what is the new 3 address code, that is what is generated, right? And this has to be concatenated with first E1 dot code, the sequence of 3 address codes of this E1, which is these 3 sequence, okay, followed by E2 dot code, that is these 2 sequence, that is T4 equal to B minus T and T5 equal to T4 into D. Okay, concatenated with this. Okay, I have 5 sequences, these sequences 1, 2, 3, 4, 5, 6. So these things are the sequence of 3 address codes evaluating the head of the production, that is E. E1 E dot code, and the value is in T6, right? So my next production is, that is here 24, 26, sorry 25. Yes, derives ID equal to E. Okay, I have the sequence of 3 address codes evaluating this. There are 3 sequence of 3 address codes, value is in T6. So new 3 address code, that is what is generated. First you request a temporary, that is ID. Okay, see here. Instance of an ID is W here. Sorry, X. So it is X equal to value associated with this, which is T6. So X equal to T6 is the 3 address code, that is what is generated. Okay, next finally, okay, you have the sequence of 3 address codes evaluating this concatenated with this. So what are the sequence of 3 address codes of this E? That is all these up to T1 to T6, then followed by X equal to T6. So all these 7 sequence of 3 address codes are nothing but the sequence of 3 address codes for the grammar symbol S. So S dot code is the final sequence of 3 address codes evaluating this expression. Understood? Okay. So I'll stop today. Tomorrow I'll take one little variation to this particular assignment statement, and then I will close this unit. Thank you. Bye. Late आता ना? हाँ? लेट झाला? आहे की टाइम? बरोबर आहे की टाइम? ताकद बढ. आज इरले.
Hello class. Today we will start with the third unit.